Now we're going to consider how you divide by a decimal. This normally bothers people a lot because people generally don't like division, they don't like decimals. Put the two together and it all seems a lot worse, but it's not too bad. So let's consider 3.46 divided by 0.2 first of all. A decimal divided by another decimal. This decimal here actually isn't a problem. That doesn't cause any difficulty at all, as we'll see later on. This is the issue. This is why things are more difficult. So let's think about this quite carefully. First of all, this sum can be written like this, 3.46 divided by 0.2. We can write it as a rather awkward fraction. Now, you should know about equivalent fractions. Let's change this fraction into an equivalent fraction, so it'll mean exactly the same thing, but it will be written using different numbers. What we're going to do is we're going to change the denominator such that it becomes a whole number. And the easiest way to make the denominator a whole number in this question is to multiply it by 10. That's fine, as long as we also multiply the numerator by 10 so that we're multiplying by 1 overall, and we will get our equivalent fraction. So we've got 34.6 being divided by 2. And all of a sudden things are much easier. Let's just be clear though that this sum, 34.6 divided by 2, has exactly the same answer as this sum, because we have only multiplied by 1. We haven't actually changed anything except how the sum looks. So 34.6 divided by 2. Write it out. Use the squares in your book to keep things nicely lined up. 34.6 divided by 2 needs to be written like this. And this point, decimal point, which came out of here, I said it wasn't a problem, and it isn't a problem because it just gets copied straight up. There's no difficulty there. 2 goes into 3 once, remainder 1. 2 goes into 14 7 times, exactly. 2 goes into 6 3 times exactly, and we have our answer, 17.3. Let's look at the next one, 1.78 divided by 0.14. The same process. Consider the sum as a fraction and start thinking about equivalent fractions. Now, what would you multiply this 0.14 by to change the denominator into a much easier whole number? You would multiply by 100. And that's fine as long as we do the same to the numerator, so that as we did in the first example, we're actually just multiplying by 1 overall. We're not changing anything. Now, 1.78 times 100 is 178. 0.14 times 100 is 14. And so we need to do 178 divided by 14. Now, I don't know about you, but I don't know my 14 times table that well. And too many people at this stage just say they're stuck. You cannot say you're stuck if you haven't bothered to write out the relevant times table. So in this case, the 14 times table. And you don't need to know it. You just keep on adding 14 every time. Now, obviously, if you get this wrong, then your final answer will be wrong. You've got to be careful, but it's not difficult to write down the 14 times table. I'll maybe take it up to about there, and we can extend it later if we need to. 14 into 1 doesn't go. Remainder 1. Put a 0 in there if you wish. 14 into 17 goes once. Now, 17, we've just divided with, is in there. The remainder, counting from the top, 14 into 17 goes once. The remainder is between the 14 and the 17. The remainder is 3. It's not this gap down here. Too many people think it is. So the remainder is 3. Now 14 into 38, 38 is in there. So 14 goes into 38 twice, with a remainder between the 28 and the 38, a remainder of 10. And I think I'll write my answer like this, a remainder 10 out of 14. So the answer to the question is 12, and we can simplify that, 12 and 5/7. That is one way of doing it. So dividing by a decimal, change the sum into an equivalent fraction, make sure the denominator is a whole number, and then use your traditional non-calculator method to finish the question off.